So hi everyone. So today we just continue the introduction about pointers. But before that, because I know pointers might be difficult, I would say it's one of the difficult concepts in C, and personally I struggle a lot when I first learned it. So I understand, I truly understand pointer until I need to prepare for this course, okay? So when I was a bachelor student, I just know a very rough concept about pointers, and I still struggle with what is an indirection operator, what is address operator, when should I add a star symbol, and why I shouldn't add a star symbol here and there. So I can understand. So please don't worry that it feels really confusing for you, but I'm try to do my best to really illustrate the concept about pointer and let you know it's not actually that hard, as long as you can truly understand or grab the basic concept or the true nature about pointers. And as long as you understand that, as long as you have a solid understanding about what is pointer, the relationship between pointer and address, then you can understand pointers and you can understand why you need add the star symbol here but not there. So I already see a lot of people submit your answer, very good. So again, before we introduce new things about pointer, I want to make sure you understand what we teach in the last lesson. So I have a 3 to 4 slide quiz, and this quiz is trying to let you test if you understand all this basic concept or not. So the first question is pretty simple here. So which of the following statement about pointer in C is true? And there are more than one correct answers. So please trying to challenge yourself to see whether you can get all the correct answers. And we already have 30 submissions. Let's try to reach 35, okay? We have 35, more than 35 students here, right? Okay. Oh, 36, great. Okay, very good. So more than 80% of the submission choose the correct answer here. So yes, a variable's pointer is the address of the variables. So if you add the address operator with a variable, that will make the whole expression become the pointer to the variables. And you can also assign this pointer to the variable. You can assign the address of the variable to a pointer variable. So that leads to the statement here. So pointer variable is a kind of variable. The special thing about pointer variable is that we use the pointer variable to store the pointer of other variable. So in other words, pointer variable is used to store the address of other variables. And if we store the address of other variable in these pointer variables, we can make this pointer variable point to the variable that the address is saving to the pointer variable. Sorry about all the things here, but I'm trying to explain completely so you can understand their relationship. And again, pointer variable have memory address. This is true because pointer variables, we have a named variable here, right? So that means that this variable also need a memory space to save the data. So that is why pointer variable itself also have memory address. And this 3 item is false because pointer variable cannot store the value of the variable directly. What pointer variable can store is the address of the variable, not the value of variables. And next is that pointer variable can store only integer value. This is obviously wrong because it can store address numbers, not the integer value. And pointer and variable have no relationship to each other. That is wrong Otherwise, why we spend a lot of time to talk about pointers and variables? Okay, so the next question is that what does the indirection operator, the star symbol here, the asterisk here, do when we use it with a pointer variable in C? So there's only one correct answer. Again, let's wait until we have 30 submissions. Okay, so let's check out the result. Very good. So around 80%, let's say it's 80% of submission choose the correct answer, so yes. So the indirection operators help us to access the object, the pointer variable point 2. So it is not convert the pointer into an integer. An integer means 1 is integer, 10 is integer. But this is not indirection operator want to do. The indirection operator can make this pointer variable become the object in point 2. So that is the purpose of indirection operator, and that is why we can use pointer variables as the alias, 别名, or you can think about another representations for the object in point 2. And of course, the indirection operator had nothing to do with assign a new address to the pointer. There is actually no functions or operator in C can simply change the address of the variable. So you need to do other things, but this is not the indirection operator can help us to do. Okay. The next question is we have a very simple program here. So this program showed how you declare a pointer variable and make it point to another variables. And we can use an indirection operators to assign a new value through pointer variables. So what will be the output of these programs? So I just tell you the answers. So if you pay attention to what I'm saying, so you should be able to choose the correct answer by now. So here we use printf, and we print out the value stored inside I. So what is the latest value stored inside I? So in the statement here, we actually update the value of I. Okay, I believe this is just too simple for you guys. So let's just check out the answers. Very good, but we still have 20% of people choose this one. So I will quickly explain it. So the value of I is 20. The reason is that here we make P point to I by assigning the address of I to P. So now you can think about the image we used a lot in the previous lesson, right? We have a P, a square here, and then we have I here. So if we assign the value of address of I to P, so P point to I, and then we use the indirection operator to P, so it can make the star P, these two together, become the object in point 2. So you can replace star P with I. So what this line do is to assign 20 to I. So that is why the output of here is 20 instead of 10. Okay, so let's check out another, a bit more complicated one. So what is the output of this C program? So here we talk about how we can make two pointers point to the same object, and we can do the pointer assignment. So here P, we assign P1 to P2. So what will be the output of this program? And I want to invite you to try to interpret each line, and you should understand what exactly each line is doing in these examples. So I believe you can just you can guess the correct answer randomly or just by a really rough understanding, but I really encourage you to truly interpret this line and to check if you really understand the purpose of each line and what's going on each line. And if you are more a graphic style, like if your learning style is kind of like the graphical style about learning, you can try to draw something down, because I'm this kind of person, so I really like to draw everything down, and then to see how each line change the image, how each line change the relationship between P1, P2, and X. Okay, now we have 36. Let's check out the answer. Okay, so the answer is 20. So why the answer is not X equals to 10 is that here we have P1 and P2, right? And here, first in this line, we make P1 point to X. So I believe most of you have no problem with this line. But what the next line do is that we assign what is stored inside P1 to P2. So what is stored inside P1? You can know this based on this line. So we just assign the address of X to P1. So the value stored inside P1 is the address of X. So what this line is doing is to assign the address of X to P2. So using this line, we can make P2 also point to X. So the following two lines is simple here. So we use the indirection operator with P1 and P2. So we make star P1, star P2 become the objects it points to. And in this example, the objects P1 and P2 both point to is X. So here I assign 10 to X, but the next line, I assign 20 to X. So that is why when I use this printf to print out the value stored inside X is 20. Okay? So yeah, so if you choose the correct answer, congratulations. But if you choose the wrong one, I will encourage you to try to identify at which line you don't understand why you think the answer is 10 instead of 20. So identify what you don't know is really important learning skill, okay? So if you don't know why you don't know, that is best case. That is the worst case, okay? So I was one of the learning strategy that's called meta learning or metacognition, meta knowledge, something like that, is to know why you don't know. And you need to identify what things you need to learn in order to know. Okay, so that is the slide on here, but I would say most of the people understand the basic things about pointer and pointer variables. So in today's lesson, we will just continue to introduce more application about pointers. We will also introduce how to use pointer with array. Okay, so we can use pointer as arguments, and this is also one of the advantage about pointer variables. For example, we can pass a pointer to the variable to the function. That is, we use the pointer variable as the function's argument. So if you still remember, we introduced this decompose function when we introduced function in the previous lessons. And when we introduce decompose function, what we're trying to do is to write a decompose function, and this function at the beginning, we want to modify its arguments. So we want to modify the arguments we pass here. We want to modify the parameter here. And before we learned the concept about pointer, there's no way we can change the argument, right? Because if we just use a regular variable, what C function will do is to copy the value in the argument and assign the value to the parameters. So there's no relationship between parameters and arguments. But now we know the pointer variable, we can actually achieve the expected function by this new version of the decompose functions. So here you can see we changed the last two parameters from the ordinary integer variable to pointer variable that can point to the integer variable. And then what we pass is that we can pass a pointer to the variable instead the value of the variables. Because we pass the pointer to the parameters, so we can use the indirection operators to change the pointer variable point to, that is the argument. So let's check out one by one to see why this new version of decompose can change its argument. So here, this is the function declaration. This is the function prototype of decompose. You can see we declare a pointer variable as the parameters. We have this int part and flag part. And the purpose of this decompose function is to split the integer part of the x from its fractional part. So let's assume that we have this decompose function and we have the function code like this. So the first argument we put in this function code is the value of pi. And then the last two arguments here is I and d. And here is a declaration of I and d. So I is a lone integer variable and d is a double variable. And here, since the decompose function, what it's required for the last two parameters is pointer variable, right? So you need to pass the value that can be stored inside the pointer variable. So what value can be stored inside the pointer variables? I believe most of you have an answer in your mind, that is address. So that is why we pass the address of I and d as the last two arguments. And how to get the address of I and d? Please don't forget about the address operator. So that is why we need to put the address operator here to get the address of I and the address of d. So the value of address can be assigned into the pointer variable. And here is a declaration of pointer variable. So again, the star symbol here is not the indirection operator, because when we declare a pointer variable, the purpose of star symbol is to tell the C compiler that this is a pointer variable, okay? So as a result of this code, we can have the figure here. So we can make these parameters int part point to I, because we assign the address of I to int part, so it can make the int part point to I. And then we can make the flag part, the second pointer variable, point to d, because we assign the address of d to this pointer variable, flag part. And then let's check out what happens if we run this line in the function body. So the first statement is to convert the value of x into the type lone int. So the purpose of this line is to get the integer part of x. So this is the value of x here. So if we convert a floating point value into an integer value, we will just get the integer part. So that is why the return value of this expression is 3. So let me try to use the pen, although it's very hard to use. So this return value of this expression is 3. Okay. Then where are we gonna assign this 3 to? So we want to assign the return value of 3 to this place. So what is this? So first you need to know that the int part is a pointer variable. And in this case, the star symbol here is an indirection operator. So what this entire what is this entire expression is that we apply indirection operator to the pointer variables. So the effect of indirection operator is to access the object this pointer variable point to. And so you can check the figure here. You know that the int part is pointing to I. So we can replace this expression by with I. So what this statement do, what this line want to do is just assign 3 to I through the pointer variable int part. So that is why the value currently stored inside I is 3. So by this line, we can modify the argument through the pointer variable we have in the function. Okay, so yeah, so this is basically what, okay. So you can replace this line with this line. This is what this line wants to do. Okay, so let's check out the second line. So second line is actually, so if you know how to interpret this line, you should be able to interpret the second line. So what the second line, basically what the second line wants to do is to subtract I from X. So what I have is the integer part, right? So we just subtract the integer part from X. So the return value is the fractional part. And then we just assign the number of the fractional part, that is 0.14159, into where the frac part is pointing to. So the frac part is pointing to D. So we just assign the fractional part to D. So that is why after this line, the value stored inside D will become like this. So we successfully finish the decompose functions, and we kind of like, we don't need to return value. We don't need return statements to return the value from function to the function code. We can actually use pointer variables to directly change the value of arguments as long as we pass the pointers of the arguments to the parameters of the function. So here is how you can use these decompose functions. So I recommend you can try to write down the same program by yourself on the computer, and then you can try to type different input here. You can pass different value here, and then try to see the outcomes here. Okay. So actually after explain this decompose function, now actually you should know, and now we know why we need to add this AND symbol when you're using scanf, right? Because before we introduce pointer, we just said that when you use scanf, always need to add the AND symbol. Now you know the AND symbol in the scanf is an address operators. So that means that the argument in the code of the scanf is pointers. And you know that for the scanf, this function, the parameter, one of the parameters for the scanf is require pointer variable. So using this pointer we provided here, we can tell scanf where to put the value that is read, because we can use scanf to store the user's input to the variable, right? So how the scanf know the location of the variables? That is through the address of the variable we pass here as the argument of the scanf. So although the scanf's argument must be pointers, so we need to put the pointers here, but it's not always true that every argument needs the address operators as long as the argument is pointers. So we can check out the case here. So in the case here, we have we have a pointer variable called p, and we make p point to I. So if I want to use scanf to store the input to p, when I'm trying to do that, actually I just write down p here instead of and p. So I want to invite you to think about why, in this case, we don't need to add the address operator to p. In this case, why we can just put down p here. So all you need to keep in mind is that what scanf requires for its argument is a pointer variable, and p itself is already a pointer variable, and it points to I. So that is why we don't need to add another address operator to make p become pointers. Because in this case, what I'm trying to do through this line is to save the input value to I through p. P is a pointer variable point to I. So now you know that when you use scanf and the argument here is already a pointer variable, if that is the case, you don't need to put the address operator. You don't need to put the and symbol for the argument of the scanf. So the reason is that p is a pointer variable here, but what the scanf here is trying to do is to store decimal integer value to p, but p itself is a pointer variable. So you cannot just assign an ordinary decimal integer value to the pointer variable, because the legal type of value for pointer variable is the memory address. So you need to store the memory address to p, not the decimal integer variable. Okay, so that is a clarification about scanf, and now you should be able to use scanf in a more flexible way with a pointer variable. So let's check out some bug you may have when you use a pointer variables with functions. So the first things you need to pay attention to is that please double check if you pass a pointer to a function successfully, because you can see in this case we have this decompose function, but when we call this decompose function, we forgot. In this case, I just forgot to put the address operator with I and D. So the first error it might have is that it will cause the type mismatch, right? Although you can do the implicit type conversions, but the value of the memory address is very different from the ordinary floating point and integer value. So if you forgot to put the AND operator, it can cause a compilation error here. And if your compiler is not that smart, the compiler might just store the integer value of I to the pointer variables. If that case happens, what will happen is that in the decompose functions, it will try to change the unknown memory locations, because it will think the memory location is the value of I. Maybe it's 10, maybe it's 0.1, but we don't know what we have in the memory address that is 10. So what it will do is to change the unknown memory location instead of modifying I and D. And then for the most of the time, I believe the latest compiler will detect the error in this case. But if you using C with a machine level device or the embedding system, something like that, if the compiler is not that smart, if you write down something like this, your device, your program will crash and have a very dangerous result. So please always make sure that if you have a pointer variable as a parameters, always check the function code you pass the pointer to that functions. So the next thing is that I want to introduce a new keyword called const. So const is short for constant. So constant means in Chinese means 常数. So that means that we shouldn't change constant things. So what this keyword can help us to do is to protect the argument from change, because sometimes for the most of the time when we pass pointer to a function, we normally assume that the function will modify the argument here. But it's possible that the function just needs to check the value of x, not change it. However, you might think that, okay, if I just need to check the value of x, why not just pass x? Why I want to pass the pointer to x? So there are some advantage of why we want to pass a pointer to x instead of x for the purpose of checking the value of x. So the first reason is that if the variable x require a large amount of storage, for example, if x is a super large numbers, passing the value of x can waste the time and space if I just want to know the value of x. And the second thing is that so if x requires a large memory size, then we can just pass the address to x, because the memory address always use the same amount storage, no matter how large the value that x have. So you can save space, you can save the execution time. So, but in this case, I just want to check the value of x. I don't want the function to accidentally check the value of x through its pointer variable. So in that case, we will usually put const, these keywords in the parameter list to tell the function, to tell the compiler that this function will not change an object whose address is passing to the function. So const, so when we want to add a const, it will go in the parameters declarations, and you need to add this keyword const before the type in the declarations. So if you write down the parameter like this, and then when you write down the function, maybe your collaborator accidentally writing the line like this, like trying to assign a new value to the objects that P is point to, then if that happens, don't worry, because you put a const here, so the compiler will know that, okay, you're trying to change a constant variable, so you will get the error message. So you won't have this like undetectable bug that you change the thing you want to change. So I will say the purpose of const is to make your program more safe, and then to have a clear documentation about, okay, this P shouldn't be changed. The object point by this pointer variable P shouldn't be changed. I just want to read. I just want to get the value of the object that P is point to. And the next applications about how to use pointer variable with function is that we can even ask the functions to return pointer value. So we can check out the example here. So in this example, we have a function called max. And in this max function, we have two parameters, a and b. And a and b are both pointer variable. And you can see for the function type, we have the function type like this. We have int, we have the star symbol here. So this declaration of the function is pretty similar with a declaration of pointer variables. So you can see if we put this type for the function's return type, you know that what this function should return is a pointer variable point to integer variables. So it's an int pointer variable. So what this function will do is to compare the value stored inside the object pointed by A and B, and then return the value that is larger than the other one. So you can see that inside the function body, we just compared star A with star B, and then if star A is larger than star B, we return the A itself, because what we want to return is the address point to the variable that have larger number. So what we want to return is not the number itself. What I want to return through this makes function is the address to the variable that have the larger number. So that is why when I use makes in the other parts of our code, of our file, we can have a makes function here. And because the parameters should be the pointer variables, so the argument here, I need to pass the address of I and j, because the address can assign to the pointer variable A and B. And what max will return is the address to the variable that have a larger value. So you can see what I use to store the return value of the max function is another pointer variables, because only the pointer variable, we can only use the pointer variable to store the address of other variables. So by getting the return value from max function, we can make p point to the variable I or j that have a bigger number. So this is how we can create a max function like this and make this function to return pointer variable, to make the function to return pointers, to make the function to return the memory address of one of the objects. Okay, so I just quickly explained the relationship between I, J, P, A, and B. But now I want to invite you to label the between these variables by yourself. So first I want to recommend you to start from this line here, and then trying to interpret, okay, what happened if we have this function code? So I will just show you the first few steps here. So here, when I call max here, I just pass the address of I and j, right? And the address of I will assign to A. So when we assign the address of the variable to a pointer variable, we can make A point to I, and we make B point to j. And what we want to do here, this line is basically trying to test whether I is larger than j. And if it is true, return A. So what's stored inside A is the address of I, right? So this is the address here. So we just have the address here and return. So actually what we have here is that we just assign A to P. So this is a pointer assignment. So we can make P point to where A is point to. So in this case, we can make P point to I. And I will invite you to try another case, that is when B have a larger value than A, so what will happen in this case? Okay, I can see most of you already. So you can, if you have a paper or pen, or you have the slides here, you can try to draw the same thing by yourself. Or if you don't really like to use your hand, you can use your brain to try to think about to try to have this image in your mind and trying to know the relationship, okay? Okay, so let's continue. So there are some restrictions about using there are some restrictions that the function about using the function to return pointer variables. So the first thing is that we can actually, so the first thing I want you to know is that a function can also return a pointer to the external variable or the static local variable. So if we have a global variable in our code, we can also ask the function to return the pointer to that local or external variable. And if we have a static local variable like this, we can also return the pointer to the static local variable. However, one thing you can never do is that never return a pointer to an automatic local variable. So if you have a local variable like this, please don't return the address to the local variable. So the reason is that if you still remember, for the local variable, it has automatic storage durations. So when the function ends, this variable will not exist anymore. So if the variable, the pointer pointing to is not exist anymore, then there's no point that we still remember the address of the variable that doesn't exist, right? So please don't return the pointer to the local variables. Always return the pointer of the parameters. Not the pointer of the parameters. So always return the pointer that you know that it will still remain after the function's end. Okay, so let's take a break. So please come back here after 5 minutes.